Hi, my name is Umang Dhaubhadel. I am a senior in biochemistry and I'm working on the reaction of benzimidazothiazolines. I am doing this project along with Eric Siganowski under Olatunji Ojo and Dr. Carl Lovely. Benzimidazothiazolines are fused tricyclic heterocycles containing nitrogen and sulfur. These heterocycles are found in natural products and have wide applications in pharmaceuticals as well as agrochemicals. Fused heterocycles like imidazothiazoles and benzimidazoles can possess anthelmintic, antimicrobial, and anticancer properties. Because of their biological activity, synthesis of novel heterocycles are of great interest. This project involves the reaction of benzimidazothiazolines to produce a new class of heterocycles. Benzimidazothiazolines, which are the starting material for the reaction of interest, are produced using two steps. The first step is the thioacylation-hydrosulfenylation of propargylamines with aryl isothiocyanates. This reaction is a cycloaddition and is promoted by silica at room temperature. It produces a thiazolidine. Different derivatives of the aryl isothiocyanate will be explored for this reaction. The second reaction is an intermolecular oxidative cyclization. For this reaction, the thiazolidines will be reacted with bis trifluoroacetoxy iodo benzene, which is also known as PFA. This reaction is done at room temperature for 24 hours. The first two steps have been reported before. The main reaction of interest is this last one, which is the ene reaction of benzimidazothiazolines. Ene reactions are intermolecular pericyclic reactions that are similar to the Diels-Alder reaction. The ene, in this case, is the exocyclic double bond on the benzimidazothiazolines. Enophiles can be a carbon-carbon double bond, an aldehyde, a ketone, or an imine. For this project, the enophiles that are going to be explored are N-phenylmaleimide, benzene, ethyl glyoxylate, and diethyl oxomalonate. All products for this project were characterized using proton NMR. These are the syntheses that have been done so far. We have used a 4-methoxyphenyl isothiocyanate and a 3,5-bis-trifluorophenyl isothiocyanate for synthesizing the thiazolidines. The methoxy derivative had a yield of 54%, while the bis-trifluoro one had a yield of 68%. The structure of the methoxythiazolidine was confirmed through X-ray crystallography. We found that the bis-trifluoro derivative solidified immediately upon addition of the propargylamine and could be purified immediately. The oxidative cyclization was done for the methoxy derivative as well as the bromo derivative. The methoxy derivative had a percent yield of 41%, while the bromo derivative had a yield of 64%. The reaction time was optimized for this step. We found that the optimal time was around 24 hours. Ene reactions were done with diethyl oxomalonate and N-phenylmaleimide. So far, the optimal temperature has been found to be around 110 degrees Celsius, and the optimal time has been around 48 hours. The yield for diethyl oxomalonate was 82%, while the two derivatives that used the N-phenylmaleimide as the enophile had low yields of around 16% and 11%. We are still in the process of optimizing this reaction. When we did this reaction with the bromo derivative, the ene product was obtained along with the starting material, which had gone through a double bond migration, which can be seen right here. The yield for this product was around 18%. For future work, we'll be testing the benzimidazothiazoline derivatives we have made with benzene and ethyl glyoxylate as the enophiles. Likewise, we will test this benzimidazothiazole with N-phenylmaleimide and the bromo and the methoxy derivatives with diethyl oxomalonate. We will further optimize the reaction temperature by using different solvents, like acetonitrile, which is a lower boiling solvent than toluene, which we have been using so far. Furthermore, we will test some catalysts for this reaction. I would like to thank my advisors for guiding me, and the NIH, the NSF, and the Welch Foundation for funding the project. Thank you.